Welcome back to part 2. Let's see what we have left in front of us. We're down this far. We're going to do some more work starting right here. We are going to be focusing on rational exponents. We're going to use them to simplify these radical expressions. With 25 as our base, put together a rational exponent with the power in the numerator and the root in the denominator. You see that that is equal to 25 to the 1/2, which we know is just another way of saying the square root of 25, which is 5. This next one has us using a as our base, so now we're using a variable. Its power is 4, that goes in the numerator. Its root is 8, that goes in the denominator. Again, that simplifies a to the 1/2, which we know is the square root of a. Number 3, I'd like to divide this one into the number and the variable. We're taking the 6th root of each, and the number is 2 to the 12th. The variable is a to the 6th. I'm going to now change those over out of radical form into rational exponent. So we'll have a base of 2. My power is 12. The root is 6. And it's being multiplied by base of a with a power of 6 and a root of 6. So we've got 2. This simplifies to 2 to the 2nd power. This simplifies to a to the 1st power, which can be written just like this. 4a. Let's do some more of these. I'm going to go back for a moment. These are all lovely. They're fairly straightforward, I thought. Lovely. But here we are on number 4, which doesn't look quite so lovely. Not at all. And the reason I say that, this has an index, a root of 2, along with an index of 4. They would have to be the same for me to be able to get something going here. Well, maybe not, because if my radicands were they're not the same either. So that's why I say this one looks kind of ugly. But let me show you how we can use rational exponents to sweeten this up a little bit. We know we've got 10 as the base. We've got a power of 1 divided by a root of 2 for our rational exponent. This one, our base is 3. Power of 1 divided by a root of 4. If I could get these both to have the same index, then I could have a single radical to express them. And 1/2 can certainly be changed into fourths, can't it? That would be 2/4. It's the same as 1/2. And then we've got 3 to the 1/4. Now I'm going to take this back into radical notation for a moment. We've got 4th roots for both of them. This has a base of 10 and a power of 2. This has a base of 3 and a power of 1. That is equal to the 4th root of 10 squared is 100 times the 4th root of 3. Now we know, we certainly could write these, and I could have done it earlier, would be 100 times, you probably already done this, I'm behind you at this point, 100 times 3, taking the 4th root of the whole thing, 4th root of 300. I think that's about as simple as we can get it. So there we are. We have a single radical expression out of something as ugly as this. If we can do that, we can do anything. We're going to change this one over. This one looks pretty ugly itself. We've got x squared, which is not the same as x. We've got 3, which is not the same as what's here. We don't see it, but we know it's a 2. We're going to convert that over to rational exponents. X in the numerator has a power of 2 and a root of 3. X in the denominator has a power of 1 and a root of 2. We know the rules of exponents. As long as we have the same base, which we do, that's fortunate. What do we do with the exponents? We subtract the exponent in the denominator from the exponent in the numerator. Let's do it. Well, not quite that simple, is it? We don't have the same denominator. Remember, anytime we've got two fractions, we're trying to subtract one from the other. In addition and subtraction, you must have the same denominator. What do we need? How about 6? To get this to 6, we multiply by 2. We know 4/6 is the same as 2/3. To get this to 6, we multiply by 3. So that is equivalent to 4 minus 3, or 1 over 6. So we've got x to the 1/6 power, which we want to write it as a single radical. All right. That'll be a radical expression with a root of 6, a power of 1, looks just like that. So at this point, I think we can handle almost anything. We just have to remember to get something to be common, either the common base or a common root, common index. Okay, here we go. This one looks a little more complicated. You notice that that's the way we always go. We start with a fairly simple example and we keep progressing. If you find that you're getting lost, my recommendation is go back to one of the simpler examples, make sure you get that one down solid, and then move on. That's going to be part of the advantage of this kind of instruction. You can stop it and go back if you want to. This first expression, and we want to get these again into a single radical. I've got Now a binomial underneath here. The good news is that we got the same binomial in both places. I'm going to change it over to rational exponents because I think that's going to help me. A plus 1, and we've got a power of 1 and a root of 3 times A plus 1 with a power of 3 and a root of 4. Same base on both of them. If we have the same base, two expressions being multiplied together like this, what do? We add. So I guess I can fit it up here. A plus 1. You can see it is really important for me to remember these parentheses because these exponents apply to the whole thing. If I don't put the parentheses in, we'll lose that information. Okay, and now my exponents, I add them, right? 1/3 plus 3/4. I need to have them with the same denominator before I can go any further. A plus 1. What's that going to be? 12, isn't it? So it's going to be a denominator of 12. Denominator of 12. To get this to 12, I multiply by 4. To get this to 12, I multiply by 3. When I simplify this, I have A plus 1 in parentheses to the 13th power and the 12th root. I'm supposed to write this as a single radical expression. So that tells me I need to do this. My index is 12. My power is 13. And this is A plus 1. That's my answer. Pretty good. I'm going to move this up a little bit. Thought I was going to need more space, but I don't. Okay. Let's see. Ugh. Different bases. Well, that means I'm going to have to look at getting them to have the same index. Before I do anything along that line, though, let's see if we can get rid of this negative. Think of this as a fraction. When I have a negative exponent, I can make it positive by merely moving it into the denominator. So that's what I'm doing. And this becomes y to the 1/4. Bases aren't the same. So I'm going to have to work on the index. See if I can get the index to be the same. What index is going to work here? Oh, just a moment. I think we have to undo something here. Just not going to undo that. Well, it's a little bit weird. Okay, let me write this in again. Y to the positive 1/4. And we have to find a common index. That's going to be 12. Now, of course, when we increase the index from 3 to 12, we have to increase the power. Keep that, keep that just the same. That's going to be a 4. Make it a nice big 4. What a mess. And this will be a 3. So now I've got, let me write it this way. I've got an index of 12. In my numerator, after I've taken that index out of there, I've got x to the 4th power, root 12 of x to the 4th power divided by y to the 3rd power. Done. So even something as bad as this can be handled. We just have to take a look at the indices and figure out what a good common indice would be that will allow us to have rational exponents. Remembering, rational means an integer in the numerator and an integer in the denominator. Here's one where you need your calculator. So if you haven't got it handy right now, pause this, go get your calculator. The 8th root is the same as raising this to the 1/8 power. We know that. That's what we've been talking about all along. With your calculator, you can apply this. So you can find any root you want by expressing it as a rational exponent. So right now, why don't you find the 8th root of 65,536? You're going to get some number. I don't know what it is. And then we're going to verify that it is indeed the 8th root by taking that number you got, raising it to the 8th power, and that will be so just to remind you that your calculator is already using rational exponents. We've got 4 slides to go. Let's see how we do here. You are going to like these. Rational exponents. We can use any rational number up here. Let's see what I can do with this to simplify it. If I say 16 to the 1/4 power, and you'll see in a minute why I'm doing that, raised to the 3rd. Now that's the same, isn't it? If you think about it. Power of a power, if I multiply these together, I'll have this exponent. The reason I like to do it this way is now I'm going to work inside the parentheses. What is 16 to the 1/4 power? Or what is the 4th root of 16? You can use your calculator to figure that out if you like. That's 2, and we're going to raise it to the 3rd power. So all of that will simplify to 8. Let's do it down here. Now this one's a little more complicated to get started because of this negative. So I'm going to always consider the fact that this actually could be expressed as a fraction. And I'm going to move the factor here that has a negative exponent to the denominator, and that helps me out because now I don't have a negative exponent any longer. Now I have to deal though with it being in the denominator. I'm going to take the root 3 and put the power on the outside. Why am I doing that? I think we're going to be able to re-express 27 to the third root as 3. And 3 to the fourth root is going to be equal to what? Well, let's see. 3 to the third root, 3 to the third power is 27. And 3 to the fourth power is 81. If we multiply 27 times 3, we get 81. So I know my answer here is nice. Well, one thing I want to point out to you when you're doing this in class, on a test, on a quiz, of course, you could put this into your calculator and get the 8. But that won't be acceptable. What I want to make sure you do is to show your steps along the way. So be sure you show how you would be getting there without your calculator. If you want to verify with your calculator, that's fine, but make sure you show me your steps along the way. How about this one? 4. We're going to take the root to the inside of these parentheses. Leave the power on the outside because what's the square root of 4? 2 to the third power is 8. Let's try this one. This one we have the added complication. We have to move this to the denominator. 9 to the 1/2. And we know the square root of 9 is 3. This one, got 8 to the 1/3 power. And we put the power on the outside. The cube root of 8 is 2. We square it. Our answer is 4. How about this one? 32. Oh, I better remember. I don't want to have to deal with this negative, so I'm going to put it in the denominator. 32 to the 3/5. Okay, 1 over 32 to the 1/5 power raised to the power of 3. What is 32 to the 1/5 power? You can use your calculator to find that out. Just make sure you show me all these steps along the way. 2 to the third power, 1/8. So we have lots and lots of examples. You can see I like these. I put together so many examples. 64 to the 1/3. We take the root and put it on the inside of these parentheses. Take the power and put it on the outside. What is the cube root of 64? That's right, it's 4. We square 4, and we get our answer of 16. And this one, I'm going to take this 1728, and I want to find the cube root of that. And then I have to square it. Wow, what in the world is the cube root of that thing? I have no idea. So you've got your calculator there. I hate to admit it, I don't have mine. I expect you to have yours. I don't have mine right here. But anyway, whatever that is, it's some number. We're going to square it, and then we'll have what final number is. You can tell me that next time we have class. This one's going to be 1 over 49 to the 1/2, which is 1/7. And now, again, 1 over 32 to the 1/5 raised to the 7th power. Well, what is the 5th root of 32? We've seen that again and again. It's 2, and then we're going to raise it to the 7th power. Oh my goodness. Well, 2 to the 5th power equals 32. 2 to the 6th power then must be twice that, right? We just double it, times 2, 64. 2 to the 7th power has to be 128. So my answer is 1 over 128. Nice. Let's see where we are. We must be getting close to the end here. Seems like we've been going forever. Yep, here's another one. Oh, we've seen these already. Didn't we see these in a previous lesson? So all I want to emphasize here is when you're simplifying a radical expression, you factor out all the powers that match the root. If you're taking a 3rd power, let's say we had 81. We're taking the 3rd power of that. Well, we could rewrite this as 3 to the 4th power. We could have done other things too, but so I've got 3 to the 3rd power, 3 to the 1st power. And we know if I'm taking the 3rd root and the 3rd power, those cancel each other out. Radical disappears, and I end up with 3. Now the one I couldn't take out from under the radical, I couldn't take one of the 3's because I could only take the 3rd powers. So if it wasn't to the power of 3, then I couldn't take it any further. Factor out all the powers that match the root. You must get the root index as low as possible, and let me give you an example of that. We had one recently. Let's see if I can remember it. It was taking the 8th root of 64. And what do we do with that? Remember what we do with that? We said 64 to the 1/8. No, what in the world did we do with that? 1/8 power. And I guess we recognize that 64 could be expressed as an even power, because that could be 2. What is 64? I'm just going to go back a minute. We just had it. 64 is 2 to the 6th. So going forward again, 2 to the 6th. So we rewrote it as instead of a base of 64, a base of 2 to the 6th power and 8 root, and we recognize that that would be 2 to the 3rd power and 4th root, which could be written as the 4th root of 2 to the 3rd power, which is 8. So on that one, we had taken it from a root of 8 and reduced it to a smaller index. And that is required. If you're simplifying, you have to get it to the smallest index. And finally, the denominator has no radicals. So what do you do with that? You manipulate it so that you get that radical into the numerator. Wow! Well, that's part 2. That's the last part of rational numbers as exponents. And I think it turned out pretty well. Let's see. We'll do something creative here. I look forward to seeing you in class very soon, and we'll work some of these problems.